My project is to design and test a system to harvest uranium from seawater. The way you harvest uranium from seawater is there's a fiber that you can submerge in the ocean for about 30 to 60 days. And uranium ions, as well as other metal ions, will literally stick to this fiber. So the chemists have done an amazing job of finding what fibers work well, testing them in the lab setting, testing them a little bit in the ocean setting. But there's never been a real design of a machine that might move these guys autonomously. At MIT, we're really taking a dynamically different approach to how you might deploy these in the ocean. So I specifically worked on the machine to move the fibers and the shell enclosures for the fibers, which allow them to be moved in a much rougher environment than if they were just on their own. We've really been the only team that's put something out in the ocean and just let the ocean go at it, and it autonomously keep moving as we sample the uranium. So that has been really exciting. So my role in the project is to design this machine that might move these fibers and do things autonomously, so you could reduce the number of ships you need to service these deployment bases. And so this project is part of a larger initiative with the Department of Energy. And we are just one group out of many at different national labs, at different universities that are all tackling different pieces of this project. So communication's definitely been extremely key. I think when I listen to someone's presentation or read a paper, previous work really gives me an insight on why what I'm seeing or reading is important. Why is this person's work relevant? What's the motivation behind it? And why are they investigating this path versus another path or another technology? One thing that I think people do that you don't necessarily have to do is a lot of people incorporate previous work very chronologically. Like, this person did this in 1970, so-and-so built on it in 1990. I don't think you necessarily have to approach previous work from that respect in a timeline form. Are there maybe different modules of something that different people explored and it just happened to be at different times, but you focus on each module and which module you might be focusing on in your research. Establishing previous work is extremely important when I present our designs, because a lot of people have never heard of harvesting uranium from seawater, ever before in their lives. And then showing the kind of deployment schemes that have already been done is also really important, because a lot of those deployment schemes are pretty simple. The first one just involved braiding the fibers into a mat and deploying that on a pretty standard mooring structure that a lot of marine folks know how to make. And the second one was a little bit more unique in that it was a buoyant braid that was deployed like a kelp forest. So the first slide is a comparison of land-based uranium resources versus seawater-based. And so what's interesting there and what we're trying to highlight is the fact that currently land-based uranium is a much smaller amount of the total uranium that we have on Earth. The vast majority of it exists in seawater. And at the same time, we're only getting uranium from land. So seawater uranium is a vastly undertapped resource that is one of the big motivations behind why we're researching this as part of my project. It's important to start with this because you really want to set the stage of where do we currently get our uranium from, and how does the landscape look on Earth, and why might you want to switch from land to seawater. And those numbers are showing us that at our current rate of usage, we're going to be running out of land-based uranium in the next 100 years. So in the second slide, we're really trying to highlight what has already been done in terms of the machines and deployment schemes you might use for harvesting uranium from seawater. What we're trying to highlight is that we're able to reduce the costs associated with the mechanical design, and we're trying to highlight where those reductions in cost are coming from and how that's related to the design itself. Like, our mechanism, for instance, is autonomous. So that can reduce a lot of the cost associated with labor, which is a big cost in the previous two schemes. And what we're also trying to do is we're trying to determine and compare what the total price of uranium is from each of the schemes, to be able to compare that to the price of uranium we might need it to be in order for seawater harvesting to be feasible. And we're also trying to compare how much of the total cost the chemicals make up. So like I said, I'm a mechanical engineer, so I'm really focusing on the design and mechanical side of the total cost. But I also want to show that I've done all we can in that area. And what's left is really, we need a lot more research done on the fiber adsorbents and reduce the cost, their costs, which in turn will reduce the total cost of getting uranium from seawater. What I've been taught is that you want people who see your visual to get the message very quickly. So if you want to highlight that your method is faster than another method or cheaper than another method, there are ways of creating like a bar chart could quickly show the difference in cost or speed or something, and you want people to be able to quickly get that conclusion from your quantitative data. Personally, I try not to put a lot of text on my slides because the whole point of my presentation in my mind is you're there to talk to your audience. So you should be providing the text for your slides, and maybe a few key takeaways I put on the slide if someone tunes out can quickly get back on track. I try to put a picture or an image or a graph on at least every single slide, even if it's just like something to break up the text and add more white space. I also try to use color coding. So when I'm describing an equation, I color code the different variables and then have definitions underneath by color. So it's very quick to see, well, alpha means this, beta means this, and so on. You often get different feedback, and some people will be like, slide 7, I had no idea what you were trying to say, and that bar chart was very confusing. And so that forces me to start thinking, okay, is there another way I can present this? What am I actually trying to present? Is a bar chart the best way to do it? Maybe another kind of chart. Maybe I need a table, what do I want to communicate?